Mark, when it comes to the electric grid, having a digital twin of the electric grid is seen as the Holy Grail. What do you mean?
Well, to simulate what's going to happen on the future grid, we need to create a digital twin in order to replicate and simulate future outcomes. And to do this today is very challenging. But we're creating new ways of adding sensors and edge computing to do that. And by doing that, we're going to be able to simulate scenarios that incorporate more distributed energy resources into the grid and take care of a bidirectional grid that is very different than the grid that we have today.
And if I may, it's not just, a lot of people think of a digital twin as being a graphical representation. The key word there is simulate.
That's right.
What happens if I'm putting in more interconnectors, if I get more connection requests, if I get more EVs plugging in? It's all that simulation, right?
That's right. This is a virtual twin of a physical asset. And really why that's important is because you do want to be able to simulate. And today, the interconnection queues for so many energy companies are so long, right? I think the average in the US might be even close to 3 years. So, to do these studies and to be able to understand the impacts, there's both the simulation aspect, but then there's also the overall manual process of understanding permitting and requirements and regulations and all of that. So when you have a grid and you can simulate it and you can see it, and then you can add on top of it agentic AI workflows and other things, now we're talking about a whole different ballgame.
Now, some folks will be familiar with your NVIDIA Omniverse.
Yeah.
Where does that fit into all this?
So the Omniverse is the platform that's going to pull this all together. Today, it's a lot of disparate different models and programs and digital twins of independent assets. The Omniverse will allow for us to plug all of those assets into a single pane of glass and show the entire grid and include the metadata and the actual information that's connected to each of those assets, which is critical for simulation.
Correct.
And then the goal is, how do we work with the largest simulation companies in the world to basically create more robust simulators that can actually do a more robust full grid simulation and not just pieces of the grid.
Now, another thing you're doing a lot of work on, edge AI, more and more AI, Gen AI going out to the edge. What's happening there?
That's right, that's right, that's absolutely true. Everything we're doing is a 3-computer problem, right? So it's creating the AI, it's simulating, and then it's basically distributing. Some people look at robots or autonomous cars. I look at electric meters, transformers, reclosers, conductors. And how do we move that AI out to the edge so that instead of having a million fleets of one device, now we have one fleet of a million devices. And as things learn from different situations, we can take those anomalies and those learnings, update the models, push them back out to the edge, and update. And every device gets smarter. This is what we call a software-defined grid.
The pace of change, a couple of years ago, we were saying, oh, it's getting really quick. Today, you look and what we'll hear here this week is, and then onto DistribuTech next week. It's fascinating. Last question. Personally, anything you're looking forward to hear this week?
Well, this is always a great week, and I always look forward to the keynote, but I'm sure there's going to be a lot of big announcements across the industries and across our tech. But really, we've got some major announcements coming with some of the largest energy companies in the world, from transmission and grid operators to power producing companies to large EPCs and the innovative work that they're doing. And I just can't wait to get it out in the public eye.
Well, by the time we have this published, it'll all be out.
Awesome.
We could tell you now, but then we'd have to delete it.
Yes, yes.
Come here, great to meet you. Thank
Great
you so
to meet
much.
you as well.